Dear students, firstly I will introduce myself, Professor S. Chaudhary, working as an assistant professor in electrical engineering department of SND College of Engineering and Research Center. So up till now in the high voltage engineering, we have seen the breakdown in the gases, different points concerning with the breakdown in the gases. When we are going to see this breakdown in the gases, we have seen the different methods for how the breakdown occurs, for the different theories for that one, why we are going to use Townsend theory, why we are going to use Stimmer's theory, what is the primary ionization and secondary ionization. We also seen the different term mechanism, field division mechanism, all these mechanisms we also seen in this case of breakdown in the gases. Now, the second unit concerning, we are now going on the second unit, that is going to be the breakdown in the liquids and the solid dielectrics. Breakdown in liquids and solid dielectrics. So, firstly, we will see what is the breakdown in liquids. It is what are the different theories that are available to explain the breakdown in the liquids. In the last lecture, I have told you that, if you remember, there are two types of the liquids, pure liquid and the commercial liquid. What is the difference between the pure liquid and the commercial liquid? Pure liquid has no impurities in this case. That is the best example for that one. If we are also seeing that is going to be the hexane. But in commercial liquid, though it may be used as an insulating medium, it contains certain types of the impurities and the quantities of the impurities. So, when we are going to see conduction and breakdown, we are going to considering the commercial liquid. It means how the conduction and breakdowns in the liquids are going to be occurring. So, there are three types of the methods for studying the conduction and the breakdown in the commercial liquid. There are three methods. Three theories are available. First one, suspended particle theory. Second one, cavitation and bubble theory. And the third one, stress oil volume theory. So in this lecture, you will see firstly one, that is a suspended particle theory. What is the difference between the suspended particle theory and the cavitation and bubble theory? Firstly, when we are going to study these two theories, so firstly we will have to see what is the difference. The difference is that in the case of suspended particle theory, epsilon 2 is less than epsilon 1. Now we are going to say what is the epsilon 2 and what is the epsilon 1. Surely you have the question when I am telling that suspended particle theory is applicable when epsilon 2 is greater than epsilon 1 and cavitation and bubble theory is applicable when epsilon 2 is less than epsilon 1. So surely the question arises in your mind that what is the epsilon 2 and what is the epsilon 1? Epsilon 2 is nothing but the permittivity of that impurity or that particles that are in the liquid. And epsilon 1 is the permittivity of the liquid itself. So these are the two theories that we are going to consider in suspended particle theory. And so when we are going to see a commercial liquid, so firstly we will see the suspended particle theory. Firstly, we will see suspended particle theory. In the breakdown in commercial liquid, the presence of solid impurities cannot be avoided. When I have told you the definition of pure liquid and the commercial liquid, then at this time I have told you that the difference is that in commercial liquid there are certain types of the impurities. They may be in the form of fibers or in solid particles, they may be in the form of fibers or the solid particles. So, in this case, what happens? The force exerted on that one, the force exerted on that particle, spherical particle of these impurities is given by F is equal to 1 in bracket epsilon 2 minus epsilon 1 bracket completed divided by 2r cube 2 epsilon 1 plus 2 epsilon plus epsilon 2 gradient of E2. Gradient of E2. E square, sorry, gradient of E square. So this is a simple formula, the force exerted on the particle that is going to occur. So next one we will see this is the see here in breakdown in commercial. We see breakdown in commercial liquid. The presence of solid impurities cannot be avoided. These impurities will be present as a fibers of the dispersed solid particles. The permittivity of these particles are E epsilon 2 will be different from the permittivity of the liquid epsilon 1. If we consider these impurities to be spherical particles of the radius r and the applied field is E, then the particle experience a force F is equal to 1 into epsilon 2 minus epsilon 1 divided by 2r cube 2 epsilon 1 plus epsilon 2 gradient of E square. So this is a simple suspended particle thing. So what will happen when the force is directed? We have seen the formula for the force. Now where it is going to be, in the direction to in the direction there are two conditions given. The force will be directed towards areas of maximum stress if epsilon 2 is greater than epsilon 1, for example, in the case of presence of solid particles. Like paper in liquid. When what will in the maximum stress area where epsilon 2 is greater than epsilon 1, this happens in the case of like the paper in the liquid. On the other hand, if only gas bubbles are present in the liquid, here it is written against, then epsilon 2 is less than epsilon 1, then the force will direction of the area of the lower stress. The force will be in the direction of the lower stress. But in the case of first one, we will see in the maximum stress. In this case, what is the? It is in the towards in the direction of lower stress. See here, in the case of lower stress, if the voltage is continuously applied or the duration of the voltage is down, then the force drives the particles toward the area of maximum stress. If the continuous supply, DC supply is given, that is the continuous supply, and or the duration of the voltage is long, then what will happen? The force drives the particles toward the area of maximum stress. If the number of particles are large, it means more than one, then they become aligned due to presence of these forces and thus form a stable change bridging the electrode gap, causing a breakdown between the electrodes. What if the number of particles present are large? Not what we will see both cases. When single particle is acting, in this case also we will see, and when the large number of the particles are present, we will also see. So what in the first one? If the number of particles present are large, they become aligned due to these forces and thus form a stable change bridging the electrode gap, causing a breakdown between the electrodes. I have already told when we have studied the breakdown in the gases. So I go, what do you mean actually breakdown? Breakdown means conduction of the current between the two electrodes. Stable change bridging the electrode gap causing a breakdown between the electrodes. The gap is bridged. The gap is bridged, and this bridge is going to be causing the breakdown between the electrons. Now, second case, if there is only one single conducting particle between the electrons. In the first case, what we have seen, there are large number of particles are present. In second case, what we are studying, there is only a single particle is available between the electrons. It will give rise to local field enhancement depending upon its shape. What the shape of that single particle? It is going to be affecting the breakdown in the commercial liquid. In the case of suspended particle theory, if this field exits the breakdown strength of the liquid, local breakdown will occur near the particle, and this will result in the formation of the gas bubble. First case, when we have seen the large number, there is no gas bubble. But when a single particle is only available, then there is a gas bubbles are formed, and which is causing the breakdown in the liquid. Remember the difference. First one, bridging the electrode gap and in the large particles, then the breakdown occurs. But in this case, the gas bubble in the single particle case, gas bubbles are formed, and these gas bubbles are causing the breakdown in the liquid, it means in the transformer ion. Now, second one, the cavitation and the bubble theory. Second method or second theory, that is going to be the cavitation and the bubble theory. It was experimentally observed that in many liquids, the breakdown strength depends strongly on the applied hydrostatic pressure, suggesting that a change of phase of medium is involved in the breakdown process. It means hydrostatic pressure will come, the phase of the medium is also going to be considered, which is, in the other words, means that kind of vapor bubble form is responsible for the breakdown. See here, what is the name? Cavitation in bubble. It means in this case, the vapor bubbles are responsible only for the breakdown of the liquid or in the transformer oil. So it is called as a cavitation in the bubble stage. The following procedure have been suggested to be responsible for the formation of the, it means what are different reasons that are different processes that are available for the formation of the vapor bubble. How these vapor bubbles are found or formed in the case of cavitation in the bubble stage. So this is four here. What are the first one? Gas pocket at the surface of the electrode. If the gas pockets are available on the surface of the electrode, then they are causing for the formation of the vapor bubble. Second one, electrostatic repulsive force between space charges, which may be sufficient to overcome the surface tension. I already said in the case of bubble breakdown in the gases, the energy must be more than the surface tension. Must be more than. So in this case, sufficient to overcome the surface tension. Now third one, gaseous product due to dissociation of liquid molecules by electron collision. In the case of breakdown in gases, we have seen what is the electron collision, because there is one method that breakdown in gases due to electrical collision. So in this case, gaseous product due to dissociation of liquid molecules by the electron collision. And the last one is the vaporization of the liquid by corona type discharge from sharp points and irregularities on the electrode surface. If there are sharp points are available on the surface and the surface is not regular, or there are irregularities on the surface of that electrode, then there is going to be the gas bubbles are forming. What will happen? Once the bubble is formed, will elongate in the direction of the electrical field. It will elongate in the forms of the electric field under the influence of electrostatic forces. The volume of the bubble remains constant during elongation. Second, third one, we have seen trace oil volume theory. But in this case, what happened? The volume of the bubble remains constant during the elongation. Breakdown occurs when the voltage drop across the length of the bubble becomes equal to minimum value of Bachel's curve for gas in the bubble. It will happen when only breakdown occurs when the voltage drop across the length of the bubble becomes equal to minimum value of the Bachel's curve for the gas in the bubble. Once the bubble is formed, it will elongate in the direction of the electrical field under the influence of electrostatic forces. First sentence is the same one. Now we will see in the next one. So up till now we have seen the two theories, that is going to be the suspended particle theory and the cavitation and bubble theory. I have told you already that what the difference in the case of suspended particle theory, epsilon 2 is greater than epsilon 1. But in the case of cavitation and bubble theory, epsilon 2 is less than epsilon 1. So in the next lecture, we will see what is the space volume theory.